Okay, good morning, grade 11s, and today we're going to do a couple of efficiency experiments. We're going to have a little competition between three different ways of heating 2 cups of water. So here I have 2 cups of water. It's 500 mils, okay, and we're going to use a stove, a kettle, okay, and a microwave. Our kitchen is really messy right now, so I'll try not to show too many pictures of that. Okay, so first, how do you do the experiment? Well, it's pretty straightforward. You take a thermometer. Okay, you measure the initial temperature of the water. So I'm just gonna wait a second for the temperature to stabilize in there. Okay, it's probably pretty close to room temperature. I just got it out of the tap though, so sometimes it's a little bit colder. All right, so this is stable at around 20 degrees Celsius. Okay. Next, we're going to put this in a. Actually, you know what? We'll give it a better chance. So we'll put it in this metal kettle here. Okay. And I'll pour the water in. So water's initially at 20 degrees Celsius. Okay, you pour it in. Get the cap on. Okay, and now I'm going to turn on the element. And when I turn on the element, I have to start a timer. Okay, so I'll do that on, what I'll do is I'll set the timer for 1 minute. Okay, so I've got a 1 minute timer there. All right, now I'm going to turn it on and start the timer. So I turn it on maximum, start the timer. Okay, and now you'll see that the element starts to heat up. I might leave it for 2 minutes because this probably will not heat up that effectively in 1 minute. You can fast forward this video if you don't want to watch the pot get hot. Okay. Now, by the way, this is heat transfer down here by conduction. Okay, so there's direct contact between the metal pot and the heater underneath. And so what happens is, by conduction, you get some heat coming up there. Now you can see that there is light, so there's a little bit of radiation, but it's mostly by conduction here. Okay, so that's 1 minute. I'm actually going to put another minute. We'll call that 1 minute and 5 seconds, let's say, since it took me a second there to do it. This is supposed to be a fast boil thing. One thing I don't want is I don't want the water to boil. That'll throw off my efficiency calculation. It's not even close. It's a little bit, a few drops of water spilling off the side there. All right, I'm down to around 20 seconds left. Starting to hear some cavitation inside the kettle. Okay, let's make sure it's not boiling. Oh, it's getting hot though. Okay. All right, I'm ready to stop. I'm going to turn it off in 4 seconds. All right, now I turned it off. Now the thing with a experiment like this, we have to, there's still some heat transfer going on. We see the element now is turned off, so it's no longer glowing red, but there's still some heat transfer taking place because the element is still hot. And we're going to be fair to our heater here and give it like a minute or so. And what I'll do is I'm going to put the thermometer in there. I'm going to let some of that heat escape. I'm going to put the thermometer in. You can see it's getting pretty close to, it's not quite boiling yet, but it's getting there. And what I'll do is I'll just note the temperature right now. Okay, so you can see that red line moving up just past 70 degrees. That's definitely scalding hot at this point. It's slowing down. Right now we're at 70. 74. Still rising quite slowly. 75. All right, so we'll let it sit for a minute. What we're doing now is conduction takes time. Okay, so there's heat that, to be fair to the burner had still generated down here that's still conducting up into the pot. And so what we're going to do is we're going to wait till we see the highest temperature that this thing reaches. Okay, we're getting close to 80 degrees Celsius. Okay. And I'm just going to note its final temperature, which will be the highest point. It's going to be losing some heat to the environment. There's nothing much we can do about that. You can see there's some convection taking place here as some hot water vapor is rising out of the container. So there are some heat losses, but it's an efficiency lab. Of course, we're going to get some losses. Leaving the cover on would help, but all right, I'm at 80, 81 right now. Okay. Once it starts to fall, we will mark that as our final temperature. All right, so while that's doing that, what I'm going to do is I'm going to fill another quantity of tap water. So I have another 2 cups of water here, and we're going to use a kettle. Okay, now the kettle, I got this one from school, so that dirt came with it. By the way, my water is at 83 now. Okay, we're just going to keep watching that. So my water here, I'll measure the temperature in a second. We're going to put it into this electric kettle. This electric kettle is 1,000 watts. Okay. It says it somewhere on the bottom. Okay, 1,000 watts. And what we're going to do is we're going to put the water inside. And by the way, before you want to see how this works, the kettle has a heater inside. That's a heating element that you see down there. So it's also by conduction. The difference is here, the heater here is underneath, okay, for this guy. The heater here is directly immersed in the water. So this is called an immersion heater, right? Where the water is, in direct contact with the heater in this case, where here it has to go through the pot before it can get to the water, right? So you can probably guess which one is more efficient, right? 83. Okay, and remember, efficiency is all about minimizing waste heat. Okay, you always get some waste. You always get some, in other words, some heat in this case that will not stay in the water, if you like. It escapes, okay, into the environment. And so we get, all right, our highest temperature was 83. Now it's dropped to 82. So we'll take 83, 20 degrees as our initial temperature, 83 as our final temperature, and that was 2 minutes and 5 seconds. Okay. All right, now we're going to measure the initial temperature of this water again. And I should write some of these numbers down so I'm sure I remember them. Okay, so it was 20, 83 in 205. That's the stove. And by the way, the stove element is 3,000 watts. Okay. All right. So now measuring the initial temperature of my water. Seems to have, the tap water is a little warmer this time. Odd. Okay. Sometimes the water in the pipes in the house gets warm because of the furnace activation. So this water right now is at 24 degrees Celsius. All right, we'll go 24. Okay, I'm gonna pour this into my heater here. You can see that the element's completely covered in water. This one, I'm going to only turn on for 1 minute. Okay, as soon as I plug it in, it's on. So I'm gonna go timer. Okay, so we'll just let that go. And then I'm gonna get a third experiment ready with my microwave. So another 2 cups of water. Then measure the initial temperature. Again, it's around 24 degrees Celsius, so that's fine. This guy's almost done. I unplug it. Stop the timer. Okay. And as you can see, this one is already getting quite hot. So I'm going to put my guy in there. Let the mercury, or not the mercury, but the alcohol in the thermometer rise. Okay, we'll see what the final temperature is. It's just passing 50. Okay, and in the meantime, we'll do a microwave experiment. So this initial temperature is 24 degrees Celsius also. And I'm going to put that in for 1 minute. And the microwave works by radiation, so it's the that one's a little different. These two are by conduction, and the microwave works by radiation. Okay, so it actually hits the water with microwaves. All right, I'm at 50. I don't know, 53. Yeah, it's at 53 right now for the kettle. $53 degrees for the kettle, yeah. Looks like that might be the final temperature. Let's give it another minute. See if the temperature starts to drop. Yeah, it's already started to drop. So we're gonna go with 53. And then we'll quickly do the microwave here. Take this out. Throw it in here. Just gonna make sure it's well mixed. Microwave is at, looks like the final temperature is around 51 degrees Celsius for the microwave. A little bit less. Yeah, well, 51. Yeah. Okay, and the kettle got up to 53. Let's just make sure. Yeah, we'll say 54 maybe for the kettle. And the microwave, 50. All right, so that's, we just collected all our data. Kettle versus microwave versus stovetop. Okay, now the stovetop is the most powerful of the three at 3,000 watts. Okay, so that gives it, you know, it's probably about 3 times more powerful than the kettle. That doesn't mean it's the most efficient though. So let's go back. I'm going to go back to OneNote, make another video where it shows you how to calculate the efficiency of these 3 heaters. And then you can decide for yourself what's the best way to heat water if you want to have the most efficient method.